So today we're going to be presenting our quantitative article analysis for research communication. I'm Lila Tanguma, and today my group mates are Annalie Mora, Melanie Saavedra, Nayeli Ramirez, and Melanie Baltazar. Oh, okay. So the quantitative article that we were studying was Instructional Communication Predictors of 9th Grade Students' Effective Learning in Math and Science. And the researchers involved were Timothy P. Motet, Ruben Garza, Marion L. Hauser, Summer Jules, Lisa Furler, and Stephen A. Beebe. Okay, so the first thing we looked at was the purpose statement. So what is a purpose statement? So the purpose statement is usually found in the abstract in the very beginning of the article, and it states pretty much the overall aim or goal of the quantitative study. So the purpose statement of this specific study that we were looking at was to examine how students' perceptions of their teachers' instructional communication behaviors were related to their effective learning in math and science. So the next thing we looked at was the researcher's rationale. So this asked pretty much, why did the researcher conduct the study? And there were a few reasons. First off, math and science education in the US has received increased attention. Jobs requiring formal math and science is projected to increase 4 times faster than qualified individuals. Students' level of interest in pursuing math and science in higher education starts to develop as early as 9th grade. And overall, the researcher just pretty much wanted to answer the question, do perceptions of teacher communication behaviors influence students' development of an appreciation for or value for math and science?
Variables. The study evaluate 4 major connections between the variables of teachers' communication, behaviors, and effective learning. Number 1, whether teachers' communicate behavior predict 9th grade students' desire to pursue additional study and careers in math and science. Number 2, teachers' communications behavior are related to students' study strategies. Number 3, there are differences in student perceptions of their effective learning between the math/science and non-math/science contact areas. Number 4, there are differences in student perceptions of their math/science and non-math/science students' instructional communication behaviors. The literature review breakdown. The literature review first examines effective learning through the effective learning theory, which argues that there is a concept that evokes a response that determines its rejections or acceptance. Upcoming, the influence of teacher communication behavior on students' effective learning was examined by the characteristics of nonverbal immediacy, clarity, content relevance, and teacher confirmation. Literature review breakdown. In addition, the influence of teacher communication behavior on student study strategies consists of various theories that altogether verified a positive correlation between efficient teacher communication behaviors and student study strategies. In conclusion, math/science and non-math/science instructor communication differences were investigated to determine the degree to which a subject holds leverage of teachers' communication behaviors, as well as this idea applies to student active learning.
Hypothesis and research questions. Research question number 1, does teacher and student sex interact to impact student math/science effective learning outcomes? This is non-directional and two-tailed. Research question number 2, what predictor variables, teacher communication behaviors, and student strategies account for the most variance in math/science and non-math/science students' effective learning outcomes. This is directional and two-tailed. Research question number 3. Do students perceive more math/science teachers using significantly less nonverbal immediacy, clarity, and content relevance behaviors, and significantly more disconfirmation behaviors than non-math/science teachers? This is directional and one-tailed. Hypothesis and research questions part 2. Hypothesis 1. Teacher nonverbal immediacy, clarity, and content relevance behaviors are positively related, while teacher disconfirmation behaviors are negatively related to students' math/science effective learning outcomes. This is directional and one-tailed. Hypothesis 2. Student study strategies in math/science classes are positively related to their teachers' perceived use of nonverbal immediacy, clarity, and content relevance behaviors, and negatively related to their teacher perceived use of disconfirmation behaviors. This is directional and one-tailed. Hypothesis 3. Student study strategies are positively related to their math/science effective. This is directional and one-tailed. Hypothesis 4. Math/science students report significantly lower effective learning outcomes than non-math/science students. This is directional and one-tailed. Statistical test. Hypothesis 1, 2, and 3 were answered by using the one-tailed test with a Pearson correlation coefficient. Hypothesis 4 was answered by computing 5 one-way analysis of variance, while the structured type math/science or non-math/science as an independent variable, and the 4 effective learning subfactors, i.e., the attitude, the high school, the college, and the career, and the overall effective learning score as a dependent variable. Research question number 1 was the one tested by using a two-way ANOVA with student and teacher sex as independent variables and total effective learning scores as a dependent variable. Research question number 2 was tested by running 5 separate stepwise multiple regression analysis with teacher communication behaviors. That means the nonverbal immediacy, clarity, content relevance, and disconfirmation, and then the student study strategies as the predictor variables, and the 4 subfactors of student effective learning attitudes. Again, attitude, high school, college, and career as the criteria variables. Research question number 3 was tested by performing 4 one-way analysis of variance with teachers type, that means the math and science or the non-math and science, as the independent variable, and the students' perceptions of their teachers' instructional communication behaviors. That means the nonverbal immediacy, clarity, content relevance, and disconfirmation as the dependent variable.
So now moving on to the results of the statistical tests. Before any hypotheses were tested, the student's ethnicity was examined. All 6 F ratios were non-significant at a level of 0.01 that was controlled for type 1 error. On hypothesis 1, the hypothesis was indeed supported. The teacher clarity and behavior was strongly related. On research question 1, the results were used by a two-way ANOVA. The results show that the student and teacher's sex do not interact to impact the student's learning outcome. In hypothesis 2, the hypothesis was partially supported. The student's perception of their teacher's nonverbal behavior were positively related to the student's studies. In hypothesis 3, the hypothesis was supported and the student's results indicated that the student's studies were positively related to their total effective learning. In research question 2, the results found that the teacher's communications behaviors and student strategies are more predictive of math/science. The total effective learning outcomes of non-math/science students, total effective learning outcomes than non-math/science, total effective learning outcomes accounting for 23% and 20% of the variance. On hypothesis 4, it was stated that math/science students reported lower effective learning outcomes than non-math/science students. This hypothesis was indeed incorrect and not supported.
So during research question 3, it was asked whether students understand math/science teachers using notably nonverbal immediacy, clarity, and content that was related to behavior, and knowingly more discomfort in behaviors than non-math/science teachers. The results suggested that those students were using less nonverbal immediacy, clarity, and content that was relevant to behaviors and more disconfirmation than non-math/science teachers. Results explained. Overall, there were 5 conclusions made from this study. Number 1, to be expected that the teacher's use of all instructional communications behaviors would predict the student's learning outcomes. Number 2, that teachers' use of clarity and content relevance behaviors, as well as student study strategies, predict students' effective learning similarly, regardless of the course content. Number 3, that teachers' use of clarity and content relevance behaviors predict 9th grade students thinking about pursuing additional study in the math/science content areas in high school and college, as well as considering careers in the fields of math and science. Number 4, 9th grade students did not perceive meaningful differences in their effective learning between math/science and non-math/science courses. Number 5, students perceived minimal differences between their math/science and non-math/science teachers' use of instructional communication behaviors. So what do the results mean? The first conclusion was drawn because the students did not have the necessary attachments to the course content to allow nonverbal immediacy to have an effect. This also ties into the finding of cognitive learning possibly being an antecedent to effective learning, as students must know the more fundamental information to perceive math and science as stimulating and pleasing to learn. The second conclusion is due to the connection of success between study strategies and effective learning, as well as the effective communication behaviors of clarity and content relevance. A student will find a studying strategy that increases the strength of their academic performance if they find the content to be relevant. A student will also work well due to the teacher's behaviors of clarity and content relevance. So essentially, they go hand in hand. The third conclusion suggests that because of the successful methods of having 9th grade students to be engaged in math/science courses, they will likely pursue math/science courses for the rest of their education and may choose careers in these fields. The fourth and fifth conclusions clarify that 9th grade students will achieve effective learning with the successful communication behaviors, regardless of the presented subject. And that concludes our presentation. Thank you so much for listening.